All right. I think we should have 36 or 37, but I'm going to start anyway. Make sure you're all aware that you need to have 80 people to sit for the final 10. I'm going to check the attendance, before we end our lecture. Okay. All right. So we already discussed about last week the basic of nutrition, and I'm sure it's not. We just recap on the carbohydrate, protein, lipid, amino acid, and so on, and why they are important to our body, and how do we get all those type of biomolecule or macromolecules from our diet. And today we're going to continue our lesson in this course, nutritional biochemistry, and the topic for today is going to be, about micronutrients and what are micronutrients? Vitamin is one, one type of vitamins. Can you see my slides, or is still at the front page? Hello, can you see this? So the slide, freeze at the it's working now. Okay, all right. So at the end of this lecture, you something new for you. All of you should by now already have a very good knowledge on vitamins and the names of the vitamins. You should be able to know the distribution in various food sources. So how do you get this vitamin from your diet? What type of food that you need to eat in order to get these vitamins into your body? And then number 4, to understand their role in metabolism. The importance of the vitamin for our body, and to understand the sign and symptom of diseases resulting from the deficiencies of vitamin. Okay, vitamins, nothing new. We were little kids, and up to now, I'm sure that all of you know what vitamins are, and the type of vitamins. Maybe during this lecture, some of the knowledge may be something new for you in terms of the role of vitamin in the metabolism and so on. So the vitamins are a group of organic nutrients required in small quantities. We don't need much of this vitamin, or it's for it to be able to play a role in our body. We need required only small quantities of vitamins for a variety of biochemical functions, and which generally cannot be synthesized in sufficient quantities. Most of the vitamins can't be synthesized by our body, but certain type of vitamin can our body capable of synthesizing it, but most of them are cannot be synthesized by our body, and because our body are not able to synthesize this vitamin in sufficient quantities. Some of the vitamin can be synthesized, but the amount of the vitamins that being synthesized by our body is very low in order for it to be able to carry out this biochemical function. So because of this, we need to get this vitamin from our diet. So a little bit of history on these vitamins. We go back, dated back to 18th century. The first time people come across about these vitamins, and when the sailors during these periods of 18th centuries, they know that by eating lemon they can cure scurvy, and by taking cod liver oil they can cure rickets, but they don't know why. They just know that if someone has scurvy, eating lemon after a while can cure the scurvy. But when someone gets rickets, they somehow this cod liver oil cures rickets, but they don't know what actually happened in their body and what actually contains in the lemon and in the cod liver oil. So in 1912, Polish American biochemist Casimir Funk, this guy discovered this guy on the bottom here, discovered vitamin B1 in 1912 in rice bran. So, and then later on, Sir Frederick Golan Hopkins, this guy here on the left here, also studied the vitamins which he called accessory factor in milk. So this guy studied vitamin in rice bran, vitamin B1, while this guy studied vitamin in milk, because milk contains lots of growth factor and vital component. So this guy called it as accessory factors. And later on in 1929, this guy had been awarded Nobel Prize for his discovery. And then he proposed the complex that he is being studying in milk to be named as vitamin, because at that time what he has found is that all these compounds or complex contains amines, so we call it as vitamin or vital amine. So to be short, we call it as vitamin. So because we found that all of these compounds contains amines, amine group at the one side of the compound in the structure. Sorry. So we call it as vital amine. So by the time it was shown that not vitamins or amines, so some it is true that some vitamin contains amine, but not all vitamin actually contains amine. So by the time the study has been shown, numerous study after this discovery, people interested in studying about the vitamin, and they have found a lot of people come across that not vitamin contain amines, but by the time the words vitamins already so it's no point of changing it because it's easy to use. Maybe I don't know. Maybe it's the name is catchy to be used for that type of compound. So until now we still call it as vitamins. So the important vitamin, 13 vitamin in total. Okay. So vitamin A, retinol, vitamin B complex, B1, B2, B3, 5, 6, 7, 9, 12. C. Ascorbic acid, D. Fat soluble corticosteroid, E. Tocopherol and tocotrienols, and vitamin K, 2-methyl 1 for naphthoquinone 3 derivatives. So I hope that you will be able to memorize all the names of these vitamins. And vitamin A only one, retinol, vitamin B, eight type of vitamin in vitamin B complex, vitamin C, ascorbic acid, and so on. So how the vitamins are classified? Nothing new again. So um, generally, vitamins are classified into two major groups, which are fat-soluble vitamins and water-soluble vitamins. So fat-soluble vitamins, we have been taught in our secondary school, maybe, just to use uh, the term ADEK, but it's up to you how do you memorize it as long as you know what's in the fat soluble vitamin category, vitamin A, vitamin D, vitamin E, and vitamin K. All these four vitamins only soluble in fat, so they are called fat soluble vitamins. While the second group is water soluble vitamins containing vitamin B complex from vitamin B1 to vitamin B12, and as well as vitamin C. So we're going to look in detail what's the main different, yeah, the vitamin B complex and vitamin C. Generally, they are involved in the cellular metabolism. One by one of these vitamins on the water soluble vitamin group, we can see that all process, whether it's they are responsible, they play part in the energy metabolism. While for fat soluble vitamins often have very specialized function. Vitamin A has their own function compared to D, E, and K. So they have their own specialized function, not uh, like vitamins which are water soluble, which can be said that all of them are responsible for energy metabolism. Okay, water soluble vitamin, of course, soluble in aqueous solution, used as cofactor by many enzymes and not stored in our body. So what does it mean by not stored in our body is that when we uh, when we take these water soluble vitamins, it's rarely that this type of vitamin can accumulate in our body, and it's very rare that this water soluble vitamin can cause toxicity because it's not going to be stored in our body. So we need to take this vitamin. We need to replenish this vitamin daily, because after a while, when we you know, when we consume this water soluble vitamin, is going to be excreted. Some, not all, of course, not all. Our body are not that efficient to take 100% of the vitamin that we get, and some maybe 60%, 70% is good. The rest will be excreted by our body via urination and so on. So they are not going to be stored in our body. Water soluble vitamin usually contain hydrogen attached to electronegative. They easily form hydrogen bond with water molecule. So that's why it's soluble in water or aqueous solution, because it contains hydrogen. So this hydrogen, like uh, we already discussed last week on the properties of water, right? Why water, why the properties of water like this and like that. And then because of this vitamin contain hydrogen attached to, when hydrogen, you know that they tend to attach to electronegative atoms such as oxygen. So the hydrogen of the vitamin will attach to the oxygen of the water. So by forming hydrogen bond, they're going to get ionized and soluble in this water. So thiamine ferrophosphate, uh, the example for the cofactor of the water soluble vitamin that are used by many enzymes such as thiamine ferrophosphate, NADP, NAD, uh, pyridoxal phosphate, vitamin, etc. We're going to go through one by one later on. And so, not stored in our body, I already explained. So regular supplies are necessary. That's why nowadays during COVID pandemic, COVID now, I think we are entering endemic. Uh, in 1st April, we're going to consider it as endemic, right? But we are in pandemic. During pandemic of COVID-19, we have been advised by the doctors, physician that we need to get vitamin C supplement, right, every day, as high as 1,000 milligram per day. So in order for our body to have these antioxidant properties to fight this virus. So that's why we need the regular supplies for this vitamin, because they are not going to be stored in our body. So this table shows you the vitamins and their functions, more or less general function of this vitamin. For vitamin B1, or also called thiamine, coenzyme TPP, thiamine pyrophosphate, and thiamine pyrophosphate responsible for the carboxylation reaction. If you go back to your metabolism course last semester, you can, you know, you can see why this thiamine pyrophosphate responsible for the carboxylation, with what type of enzyme that needs thiamine pyrophosphate to be able to catalyze its reaction. I'm sure you know by now. If not, you can always go back to your lecture, your lecture notes from metabolism class. And then B2 riboflavin, coenzyme FMN, and FAD for electron transfer, electron transport change. Require these two, both FMN, FAD, and B3 niacin, um, coenzyme for nicotinamide adenine dinucleotides, NAD and NADP, for oxidation and reduction. B5 pantothenic acids, or also can be called coenzyme A, acetyl group transfer, pyridoxine, B6 pyridoxal phosphate for transamination, B12 cobalamin, methylcobalamin, methyl group transfer, vitamin C, one of the most famous vitamin at the moment due to this pandemic, COVID-19. So vitamin C, coenzyme for vitamin C, ascorbic acids, collagen synthesis, healing of wound, biotin, biocytin, carboxylation, folic acid, tetrahydrofolate, methyl group transfer. Again, we are going to go through one by one later on in detail, because all of this you might already learn in your matriculation or in your high school. So that's why we need to go through in detail one by one of these vitamins. So we start off with the water soluble vitamins. So if you have any question, you can always stop me and ask question, right? So the first one, vitamin B1. I'm sure maybe many of us know about vitamin B1, but when we ask what is the active form of vitamin B, not all of us can answer, right? We know vitamin B1, but we don't know what actually is vitamin B1 is. So vitamin B1 is thiamine. Because you are biochemistry student, you should know, you need to know the name or the specific name for this vitamin. Vitamin B1, thiamine, right? Thiamine. This is the structure of thiamine. Vitamin B1 contains amino pyrimidine ring, amino group attached to pyrimidine ring, The majority of thiamine in serum is bound to protein, mainly albumin. So B1 normally, if you do studies, analyze our vitamin B1 in our body, you can find that this B1 normally bound to protein, mainly albumin, and about 90% of thiamine in blood is in erythrocytes. All right, 90% is huge, high number of the thiamine in our body is in blood, in erythrocyte, the red blood cell. The TPP, vitamin B1 derivatives, or also coenzyme. So this is TPP, aminopyrimidine ring, iosxylene ring, and phosphate group attached to it. So we call it thymine pyrophosphate, TPP. The function for this TPP is of course is a coenzyme for many enzymatic reactions such as pyruvate carboxylase. Yes, I want to ask you for name. Um, I want to test whether you still can remember this. DVS3. Do we have DVS3? Letak DVS3. If you're not answering me, I consider you are absent from this lecture. Please, do we have DVS3? Yes, DVS3. Um,
Doctor,
yes.
she's here actually, but her internet is giving problem.
Okay. Maybe later on I will ask the name again. All right. Fang Min. Are you there, Fang Min?
Yes, doctor.
Okay. Can you explain to the class what reaction that catalyzed by pyruvate carboxylase? It's all in our previous carbohydrate metabolism.
Doctor, is it pyruvate decarboxylase or pyruvate carboxylase?
Pyruvate decarboxylase.
Okay, let me recall because I already forget.
Okay. How about
Is it involved in gluconeogenesis?
gluconeogenesis? Hmm?
Or or is it involved in the decarboxylation of alcohol fermentation? I'm not that sure.
Yes. All right. Okay. Thank you very much. And who wants to answer the second enzyme here? Pyruvate dehydrogenase. Easy, right? Pyruvate dehydrogenase. Siapa nak volunteer?
Doctor,
Yes, who's there?
Adriana.
Brianna, okay.
Yeah, I want to try. Is it in pyruvate metabolism? From pyruvate to acetyl-CoA, we use enzyme pyruvate dehydrogenase.
Pyruvate to?
Acetyl-CoA. Yes.
Okay, that's good. Thank you very much. Pyruvate dehydrogenase complex, the full name. All right, well, thank you. And alpha ketoglutarate dehydrogenase. Who wants to volunteer? The name is there, alpha ketoglutarate, but dehydrogenase. What dehydrogenase going going to do with alpha ketoglutarate. Ada yang nak cuba? In which in which pathway that you can find or you find alpha ketoglutarate hydrogenase?
Krebs cycle.
A cycle.
Yes, this is cycle. All right. Thank you very much, class. All right. These are some of the enzymes that generally very popular enzyme that require TPP in order to carry out the reaction. This enzyme needs TPP as the coenzyme to catalyze the reaction. Otherwise, it's not going to be able to catalyze reaction. All right, and trans-ketolase also. Okay, the importance of thymine coenzyme for energy production from carbohydrates, as well as thymine also B1 also important for proper nerve function, such as in acetylcholine and myelin, promoting growth and good muscle tone and ATP production. ATP production, of course, is related to energy from carbohydrates. And then what are the sources of this thymine or vitamin B1? Fish contain high amount of B1, liver, legume, nuts, whole grain of enriched bread, cereal, and rice bran. So these all type of foods contains high amount of vitamin B1, but there's another type of food also as well, not limited to this, but these are the most, the food that contain vitamin B1 in them. So how about the deficiencies of vitamin B1? Thymine. Because of this vitamin B1 responsible in energy production, coenzyme for energy production, ATP production, and muscle production, chromatic growth, and muscle tone. The deficiencies of this vitamin will cause loss of appetite, weakness, and not have enough energy in the form of ATP, insomnia, loss of weight because less energy, depression, well-known disorder called very is the deficiency of vitamin B1. We call it very. It's quite hard to find. It's nowadays developed country or in developing in that area, very hard to get a source of good food that contain vitamin B1. So that is why you can find huge cases of very in that type of population. So for toxicity, no known adverse effect because they are not going to be stored in our body. So they're not going to have toxicity to our body. All right, vitamin B2 or riboflavin. The structure of riboflavin here, constituent of two coenzymes, FMN and FAD. For FMN and FAD, during you can memorize about electron transport chain now, where can you see FAD and FMN takes so B FAD. These are for prosthetic group involved in metabolic reaction. Prosthetic group is the group that attached to the main structure of the compound. Without this, the compound is generally not going to be able to catalyze the reaction. So they need this type of prosthetic group in order to be catalyze the reaction and responsible in many metabolic reactions. These are the structure of the FMN and FAD. So on the left hand side here, FMN, they have the same flavin attached as a prosthetic group. So on the right hand side, we call it FAD, flavin adenine dinucleotide. So the function, we go first for the FMN. The function for FMN redox active enzyme, various oxidoreductase, including NADH dehydrogenase. You can find NADH dehydrogenase in two general energy metabolism pathway. Can you tell me which pathways that you can find NADH dehydrogenase? Balkis. Ada Balkis. We have Balkis.
Yes, okay.
Okay. Name two pathways that you can find NADH dehydrogenase. Tak ingat? Balkis, can you hear me?
Yes, yes. From ETC and oxidative phosphorylation.
Acidity and oxidative phosphorylation.
Yeah.
Okay. Nur Jasima. Nur Jasima. Do you have Nur Jasima?
Yeah.
Nur Jasima, betul ke? Is Balkis correct?
I think it is used in electron transport chain.
Electron transport chain and tu je.
Not sure.
Satu je. Electron transport chain dekat which complex?
Complex 1.
Complex 1. Okay. Betul ke complex 1? Balkis, betul ke complex 1? Is it correct?
Betul.
Betul. Okay. Right. Thank you. So NADH dehydrogenase responsible in electron transport chain, right? Complex 1. Because why? Because you can find FMN responsible in that complex 1. So for FAD, redox active enzyme as well, similarly to FMN, but FAD responsible for prosthetic group 4, succinase dehydrogenase complex, pyruvate dehydrogenase complex, already asked you about pyruvate dehydrogenase complex, and alpha ketoglutarate dehydrogenase complex. So for succinate dehydrogenase complex, can I call Nurul Farhana? Name two pathways that you can find succinate dehydrogenase.
In PCA cycle.
And number two,
Not sure. Ada tu. The other
sorry?
one.
Okay,
I just know the PCA cycle only.
PCA cycle, okay. All right, if you see the structure here, why is responsible for FAD, you can tell me the answer for the second pathway. Can I call Sofita?
Yes, doctor.
Sofita, Nurul Farhana already gave the answer of TCA cycle, and the second pathway that you can find succinate dehydrogenase is
I'm also not sure. I only know
come
about
on,
the TCA cycle.
mereka macam mana dah lupa lah semua.
ETC?
ETC in which complex?
like that.
Fong Ying. Okay, Meiki lah. Wong Meiki.
Yes, have a complex too.
Yes, banyak dekat chat box complex 2. Alright, thank you very much everyone. Okay, so complex 2 and TCA cycle, right? Okay, riboflavin, the important in energy production, of course, it's responsible in TCA cycle, and ETC complex 2 is responsible for uh, energy production, carbohydrate, fat, and protein metabolism, formation of antibodies and red blood cells, respiration of the cells, maintenance of good vision, skin, nails, and hair, alleviating eye fatigue. So these are some of the main important function of riboflavin to our body. So where can you get this riboflavin? The food that contains high amount of riboflavin, such as milk and milk products, cheese, and so on, eggs, beef, muscle, liver, and etc. So, more or less, riboflavin can be found in the animal, source. And deficiencies, itching and burning eyes, crack and sore lips in mouth and lips, bloodshot eyes, dermatitis, oily skin, digestive disturbance. Again, no toxicity, no non-adverse toxicity has been found, has been reported for this riboflavin because they are not stored in our body. We move to the third vitamin, vitamin B3 or niacin, or we call it as niacin or nicotinic acid. Another form of vitamin B3, niacinamide and nicotinamide, the active form. Left hand side here, nicotinic acid, and the right hand side, nicotinamide. The difference are on the uh, on the groups here, acid and amide. Same functions but different pharmacologies properties. Nicotinic acid and nicotinamide, they are the precursors for biosynthesis of NAD and NADP. So NAD, structure of NAD here, nicotinamide adenine dinucleotide, while NADP on the right hand side. Can you spot the difference? Who can spot the difference between NAD and NADP? Very easy, right? The phosphate group. This one doesn't attach to phosphate group. This on the right hand side, NADP, because it contains phosphate here. The function for NAD, redox active enzyme, similarly to vitamin B2, riboflavin, exists in two forms, oxidize and reduce. NAD plus is the oxidizing agent, while NADH, reducing agent. You know by now, biochemistry student, you should know why we call it as oxidizing agent when it's NAD plus, while when it contains hydrogen, we call it reducing agent. I'm not going to explain. Also involved in cell signaling and DNA repair, while for NADP, used in anabolic reaction such as lipid and nucleic acid synthesis, require NADPH as a reducing agent. All right, niacin and niacinamide. Let's see the importance for these two. Energy production, similar, niacinamide both important in energy production, maintenance of nervous system, used to treat pellagra, deficiency of vitamin B3, cholesterol lowering effects for niacin, but not niacinamide. Niacinamide has been reported to be able to treating osteoarthritis, and niacin improves circulatory problem, while niacinamide anti-inflammatory for treating acne. So this niacin, a lot of studies has been reported on the properties of niacin in cholesterol lowering effect. But some studies also point out that there's no significant difference, but that's why the cholesterol lowering effect of niacin is not that vital because still um, some studies saying different and another studies saying different. So more studies need to be carried out in order to to justify the cholesterol lowering effect of this niacin. So adverse effects cause skin blushing, while niacinamide have doesn't cause skin flushing. Sources of vitamin B3, you can get the vitamin B3 from meat, fish, nuts, and mushroom. Plant and animal sources. Deficiencies pellagra rare in Western societies because Western societies doesn't get this problem much. Maybe maybe centuries ago, but not at the moment. Gastrointestinal disturbance, loss of appetite, headache, insomnia, mental depression, fatigue because of this responsible for energy production, fatigue, aches and pains, nervousness and irritability. So this is how does it look like for people who get who've been affected with pellagra, skin lesion and dermatitis. Vitamin B5, pantothenic acid or pantothenate. All right, this is the structure of pantothenic acids containing pantoic acid and beta-alanine. So the alanine is amino acid and pantoic acid is acid. So combining these two compound here, become pantothenic acids. Pantothenic acid is essential for synthesis of coenzyme A. So we can coenzyme A is a huge compound, huge structure that contain part of the structure is pantothenic acid. So this is the acetyl coenzyme A structure. Coenzyme A structure contains pantothenic acid in the middle of the structure, an acetyl group attached to one end, while phosphorylated ADP in one end. So in all, it make up coenzyme A. Important roles of coenzyme A: acetyl group carrier to form acetyl-CoA, transport carbon atom within cell. Coenzyme A, energy metabolism, pyruvate to enter TCA cycle. I hope you can imagine in your head now how pyruvate can enter TCA cycle. Alpha ketoglutarate to succinyl CoA. The CoA here responsible for this. Without CoA, we are not going to have succinyl CoA, and then we'll disrupt the whole TCA cycle. Biosynthesis of many important compounds such as fatty acid, sterol, acetylcholine, and etc. Other reactions such as acetylation, signal transduction, deamination also requires CoA, coenzyme A. So sources of this pantothenic acid or pantothenate: nearly every food with high amount in avocado, whole grain cereal, legumes, egg, meat, royal jelly, and yogurt. So quite a lot of type of foods that that you can get vitamin B5. So that's no problem in getting this B5. You don't need supplement for this vitamin because you can eat almost every food contain this. But to get the daily requirements, I'm not sure. You have to check how much you need to eat. For example, avocado, how much vitamin B5 can you get from avocado, whole cereal, legumes, egg, meat, jelly, and yogurt. We have to check. And deficiencies for this vitamin B5, similar to other vitamin B5 deficiency, irritability, fatigue, apathy, all of this because of the role of vitamin B5 in energy metabolism, TCA cycle, as we already explained. Acetylcholine synthesis also impaired, therefore, because acetylcholine in your brain responsible for neurological properties. So when there is a defect in acetylcholine synthesis, also can cause neurological symptom, um, can also appear in deficiency. So that's why vitamin B5 is important for energy metabolism as well as for the neurological. Toxicity very rare, and vitamin B6, or also called pyridoxine, 7 form. This vitamin B6 contain 7 active form. So the rest, that we already discussed from vitamin B1 until vitamin B5, most of them, the most form for that type of vitamins are only 2 forms. But for vitamin B6 contains 7 active forms. Pyridoxine, pyridoxine 5-phosphate, pyridoxal 5-phosphate, pyridoxamine, pyridoxamine 5-phosphate, and pyridoxic acid. But 3 are the most important active form for this vitamin B6, which highlighted in blue color here, which are pyridoxine, pyridoxal 5-phosphate, and pyridoxamine. You can see the general structure. They have the same general structure, but the group that attached to it, which uh, which are different. For pyridoxine, the structure is like this. Pyridoxal 5-phosphate contain phosphate group attached to carbon number 5, and pyridoxamine contain amine group here, right? We go to one by one. We first start with pyridoxal 5-phosphate. Just a second, I need to drink water. Okay, all right, let's continue. Okay, so first of pyridoxal 5-phosphate, or PLP, pyridoxal phosphate. These by far the most metabolically active form of vitamin B6, because it's responsible or drive approximately about 168 vital enzyme process in our body. So these B6 pyridoxal 5-phosphate, or PLP, responsible for about 168 enzyme reaction in our body. That's a huge number of enzyme that required pyridoxal 5-phosphate in order for them to carry out the reaction. So based on this number, you know how important this PLP is, right? So this PLP acts as coenzyme in many in all the transamination reaction. Some decarboxylation reaction require PLP, and some deamination reaction, transfer of amino group requires PLP. They essential for red blood cells metabolism and hemoglobin formation. Nervous and immune system needs vitamin B6 to function efficiently, and needed for the conversion of tryptophan to niacin. Also responsible for biosynthesis of histamine, serotonin, gamma aminobutyric acid. maintaining blood glucose within normal range. When calorie intake is low, vitamin B6 helps to convert stored carbohydrates or other nutrients to glucose to maintain normal blood sugar level. So this is for energy production, the importance for vitamin B6 PLP for maintaining normal blood glucose is, is to help in converting the stored carbohydrates or other nutrients to glucose in order to maintain the blood glucose level, as well as in lipid metabolism. Biosynthesis of five important neurotransmitters: serotonin, dopamine, epinephrine, norepinephrine, and gamma aminobutyric acid. So these five neurotransmitters require to synthesize these five neurotransmitters, the body requires pyridoxal 5-phosphates. So in general, this PLP, highly important for energy metabolism as well as for neurotransmitter biosynthesis. So where can you get this vitamin B6 from? Breakfast cereal in turkey, beef, bananas, potato, and pistachio. Not limited to these type of foods, but these are the food that contain the highest amount of vitamin B6. Deficiencies for skin dermatitis, inflammation, stomatitis, inflammation of the mucous lining of any of structure of in mouth, glossitis, inflammation or infection of the tongue, neurological abnormalities such as depression, confusion, and convulsion also can be seen in the individual which deficiency of vitamin B6 and also cause anemia. Vitamin B7, biotin, commonly known as vitamin BH or coenzyme R. I want the class you for the next class next week you tell me why this vitamin B6 formerly known as vitamin H or coenzyme R. Okay, I'm going to pick names next week to explain to me why previously it is known as vitamin BH or coenzyme R. This vitamin B6 or biotin is a prosthetic group for enzyme involved in metabolizing fats and carbohydrates, as well as responsible in amino acid metabolism. So this is biotin with valeric side chain. Valeric is short chain fatty acids. D-biotin is a cofactor responsible for carbon dioxide transfer in several carboxylase enzymes, such as acetyl-CoA carboxylase alpha, acetyl-CoA carboxylase beta, methyl-crotonyl-CoA carboxylase, propynyl-CoA carboxylase, pyruvate carboxylase. All of these responsible for carboxylation reaction for carbon dioxide transfer. The source for vitamin B7, biotin, endogenous source by gut bacteria. So microbiota, which are the microorganisms that you can find in the gut, are capable to synthesizing vitamin B7 from diet. Liver, meat, egg yolk, mushroom, milk, and dairy products contain a high amount of vitamin B7. And the deficiencies for this vitamin B7 can cause, you can see a brittle and thin fingernail, hair loss, conjunctivitis, dermatitis in the form of scaly red rash around the eyes, nose, mouth, and genital area. Also can cause neurological symptoms such as depression, lethargy, and hallucination. Long-term consumption of raw egg white all can cause biotin deficiency. Okay. Again, one more for you to read to find why long-term consumption for raw egg white can cause biotin deficiency. Right. Again, I will call names next week to give to explain to me to explain to the class while why by consuming raw egg whites in uh, long period of time can cause vitamin deficiency. So this happened to the people that going to the gym, for bodybuilder that that keep consuming raw egg after exercising. Okay, again two. Now two assignment for you. Explain to me why called vitamin H or coenzyme R, and why consuming raw egg white can cause vitamin deficiency. Vitamin B9 or folic acid or folate, also known as vitamin BC, vitamin M, and steroyl L-glutamate. These vitamin B9, folic acid, pyridine, PABA, and glutamate. So this is the absorbed form of folic acid. Again, not all vitamin, if you consume, can easily get absorbed by our body, because the vitamins that we consume from our diet need to be converted in our body. They need to be converted to the form that can be easily absorbed by our body. Otherwise, it's going to straight into our intestine, in our gut, and then will get excreted by urine and so on. So that's why we need to convert this vitamin in the absorbable form, soluble form, in order to our body to get use to use these vitamins. So the active form for vitamin B9 is THF or tetrahydrofolate. And remember, THF is the most active form of vitamin B9. Formation of THF begins when folic acid is reduced to dihydrofolate, THF, which is then reduced to THF. So from our diet, it's not readily in THF. We're going to see the process of how our body uh, forming THF from um, from the inactive form of the vitamin B9, folic acid. The THF is a coenzyme of transferases carrying one carbon unit. Reaction participate in nucleotide and nucleic acid synthesis. So based on this statement here, we know that this vitamin B9, folic acid or tetrahydrofolate, is responsible for nucleic acid synthesis and nucleotide synthesis. So folate, this is not the active form yet. That's why we need to convert folic acid or folate into the most active form of tetrahydrofolate. This tetrahydrofolate can be used by our body to synthesize nucleic acid. Our body cannot use folate to synthesize nucleic acid. Our body cannot use dihydrofolate to synthesize nucleic acid, because uh, these two form of folic acid, B9, are not the active form. So first, when we get B9, vitamin B9 from our diet, it's always in the form of folate or folic acid. So when we ingest, when we consume folate in our body, this folate will need to be converted first to dihydrofolate by dihydrofolate reductase. The reduction mechanism process going on here. NADPH to NADP plus, folate to dihydrofolate. You can see here the structure here, hydrogen, and then once the body form dihydrofolate need to be converted to tetrahydrofolate by, again, the same type of enzyme, dihydrofolate reductase, forming tetrahydrofolate. Okay, so tetrahydrofolate, you can see the structure containing hydrogen here. Okay, folate to dihydrofolate, dihydrofolate to tetrahydrofolate, and now the body can use this tetrahydrofolate to carry out many enzymatic reactions, such as for nucleic acid synthesis. So the enzyme that responsible to in converting folate to tetrahydrofolate is called dihydrofolate reductase. Let's see the function for this tetrahydrofolate or folic acid in general, vitamin B9. So our body needs folate to synthesize DNA because it's responsible for nucleic acid synthesis. So nucleic acid responsible, uh, for DNA synthesis. So responsible for synthesis of DNA and to repair the DNA, methylate the DNA, as well as to act as a cofactor in certain biological reactions. Important role in aiding rapid cell division and growth, such as in infant and pregnancy. So that's why when pregnancy ladies, they need high amount of folic acid in the the daily amount of folic acid is increased when the for individual that get pregnant, right? Because the infant, needs high amount of folic acid for cell division and cell growth. Children, adults both require folate to produce healthy red blood cell and prevent anemia. You can get vitamin B9 from yeast, lentils, bean, leafy vegetables such as Brussels sprout and spinach. We don't see quite often Brussels sprouts being used in our country, Malaysia, and the rest of the Southeast Asian region. Brussels sprouts normally, for people in the European continent, America, they used to eat Brussels sprout, but not for us. So maybe you can cancel this out because it's not very common to be found in our country. I think we have one French student in our class now. She knows more about Brussels sprout. Maybe she used to eat Brussels sprout, but not for us in Malaysian or in Southeast Asia. So might as well we source vitamin B9 from other type of vegetable, or you can get vitamin B9 supplement. That's the easiest way to fix our vitamin B9 daily requirement. So the deficiencies for this vitamin B9, folic acid, during pregnancy may cause neural tube defects. Neural tube defects or defect of the brain, spine, or spinal cord. Normally, when it's quite rare to have this type of defects when the baby get born, but it does occur in some area where unfortunate area where the population cannot get access to good amount of good quality of food. So the baby, when born with neural tube defects, you can see at the back of the baby kind of like a hole, because the spinal cord is not formed properly during the pregnancy. Because we in pregnancy, high amount of folic acids are required for for the growth of the bone, of the spine, and of the brain. An elevated level of homocysteine increased risk of CVD, cardiovascular disease, and renal dysfunction. Also can cause low fertility. So quite important. Vitamin B9 is quite important compared to the rest of the vitamin B group in terms of specialized high requirement for pregnancy ladies. And vitamin B12, the last form of vitamin B complex in the group of vitamin B complex that we're going to discuss today is cobalamin or vitamin B12. Vitamin B12 is the most complex form of vitamin B. You can see on the right hand side here, the structure is very complex. Vitamin B12 is the generic descriptor for all corinoids compound containing the cobalt center corin nucleus. You can see the cobalt center here in the structure here. Chemically most complex vitamin. In human, there are two metabolically active coenzyme formed. The first methylcobalamin and adenosylcobalamin. is not found in fruit and or vegetable. So we need to eat meat and fish to be able to get this vitamin B12 or cobalamin. So we cannot get this vitamin or B12 cobalamin from fruit and vegetable, unfortunately. So four vitamins, cyanocobalamin. The first vitamins of B12 cobalamin is called cyanocobalamin. The name cyanocobalamin might tell you the clue contains cyanide. Cyanocobalamin, most common synthetic supplemented form of vitamin B12, uh, contains cyanide, but in a very small amount that's considered non-toxic to the cells. This cyanocobalamin can easily get converted to its active form of methylcobalamin and adenosylcobalamin. All right. So methylcobalamin and adenosylcobalamin are the two active form of vitamin B12. So whatever form of vitamin B12 that you get from your supplement, they need to be converted to these two forms here in order for the body can use them for our um, for to be able to carry out the function in our body. So the second form of the vitamins, hydroxycobalamin. This hydroxycobalamin is natural type of vitamin B12 produced by bacteria in the GI tract and from some food source. So when you eat a certain type of fruits, when the fruits that we consume get to our GI tract, there's lots of millions or trillions of bacteria that reside in our GI tract. This type of bacteria are capable to convert this food material into vitamin B12. But hydroxy vitamin B12 is readily converted in the body into active form of adenosylcobalamin and methylcobalamin. So the ability to bind to cyanide increase detoxification by converting cyanide into less toxic form of thiocyanate. So thiocyanate is less active form of cyanide and can be excreted from our body. And then number 3 and number 4, which are the two most active form, methylcobalamin and adenosylcobalamin. These are generally considered the preferred form of vitamin B12. So these active forms of vitamin B12 works with several enzymes such as synthesis amino acids to produce red blood cells. When the vitamins are required to produce red blood cells require DNA, right? So also vitamin B12 responsible for the synthesis of DNA and DNA repair, assists with other important chemical processes as well. Our body can just interconvert between these two compounds, methylcobalamin, removing the methyl, becoming adenosylcobalamin, and adenosylcobalamin attach the methyl group, becoming methylcobalamin. So whichever our body requires, they can just interconvert between these two. So the importance of cobalamins to our body in terms of proper nerve function, as just mentioned earlier in our previous slides, this vitamin B12, adenosyl, and methylcobalamin responsible for red blood cell formation or production of red blood cell, metabolizing fats and proteins, and prevention of anemia. Because to produce red blood cell also prevent anemia, and DNA production. The source for vitamin B12 in most animal-derived foods, fish, shellfish, meat, especially in the liver, poultry, eggs, milk, and milk products, all animal-based diet. Deficiency relationship to disease, pernicious anemia, nerve damage, hypersensitive skin, elderly often have trouble in absorb this vitamin. So older people might have problem in absorbing this vitamin. So in order to prevent this, older people need to get this vitamin supplement use supplement of vitamin B12 in high doses in order to help them, to have the body to absorb at least, a small amount from this high dose that being introduced to the body. Okay, right. Let's just finish about the water soluble vitamin. We already discussed vitamin B, right? B1 until B12. Now we move on to vitamin B6, one of the most famous vitamin nowadays because of its antioxidant properties, which is vitamin C and or ascorbic acid or L-ascorbic acid or ascorbate. When you get a vitamin C supplement, you can read at the back of the bottle. It says ascorbate or ascorbic acid. So L-ascorbic acid, toxic to viruses, bacteria, and some malignant tumor cells, but not toxic to the normal cells. Display antioxidant properties. This vitamin C first discovered in 1912, but not until about 15, 17 years later, 16 years later, that this vitamin get isolated in its pure form. And in 1933 was the first vitamin to be chemically produced. You can see why this vitamin C is very important. Since like how many years ago, about 100 years ago, you know, the vitamin C already been considered as the most important vitamin. So that's why this is the first vitamin to be chemically produced. Most animal and plants capable of synthesizing vitamin C from monosaccharides. However, we as a human, we cannot synthesize this vitamin C due to the mutation that occur on the enzyme L-gulonolactone oxidase. So by right, maybe the first our ancestor, maybe they have this type of enzyme L-gluconolactone, which is wrong spelling, gluconolactone oxidase, but during after maybe centuries, after a million years, or maybe I don't know, this enzyme, the mutation occurs in our body so much so that our body are not capable of producing this enzyme anymore. So that's why we as a human, we cannot synthesize vitamin C. Otherwise, it's going to be very easy. We don't need to buy the vitamin C supplement. We don't need to eat orange for the vitamin C. We just eat fruits for their fibers content, but not for their vitamins content. But unfortunately, we don't have this enzyme anymore. So we need to outsource it from other source, such as from animal and plants, right? Might as well, get from supplement. So the function of vitamin C protects body from free radical. This is the most eminent vital properties of vitamin C. Protects or scavenge, fight the free radical, detoxify the free radical that can cause damage to our cells, to our lipids in our cells. Helps form connective tissue that hold your bone muscle tissue together in the form of collagen. That's why there's lots of vitamin. I'm not sure in Malaysia, but that's quite famous in European, in America, in Korea, Japan, that they get vitamin C injection, to increase the formation of the collagen, maybe to strengthen the skin of the face. I'm not sure, you know. But in general, it can help to produce collagen. But again, for the use of vitamin C for the skin, as intradermal injection, it's not being studied properly. There's no stable reported data that this vitamin C can increase the formation of the collagen when you inject the vitamin C by injection to your face or your skin, right? And the toxicity also not being reported properly by, in general, if you talk about vitamin, water soluble vitamin, they are not toxic, but still they need to have a proper studies to, to come out with the statement that this type of, call it, injection of the vitamin C is not dangerous to the body. In general, when you talk about vitamin C, it's not dangerous, but we still need to have the proper study. So vitamin C aids in the healing of wounds, because vitamin C is responsible for collagen, muscle tissue construction. So it aids in the healing of wound, aids in the body in absorbing iron from plant sources. So if you have a good amount of vitamin C in your body, when you eat plant sources, it helps the body in absorbing the iron. The iron is, our body is not very, um, call it, not very good in absorbing iron. We can absorb it, but only in a small amount. But vitamin C can help increase the absorption capabilities of iron by our body. And then to help to keep your gum healthy, helps body to fight infections because it's toxic to virus and bacteria, so it helps the body to fight infection, prevent heart disease, and prevent some form of cancer. So vitamin C as an antioxidant, right? Vitamin C, in the form of ascorbic acid, when we ingest, when we consume in our body, when there's free radicals, vitamin C will be converted to ascorbate to dihydroascorbate, and then the dihydroascorbate reductase will convert the GSH glutathione to the oxidized GSFG. Again, we already learned this in our food biochemistry, right? Food biochemistry, right? Okay. So GSH to GSHD by dihydroascorbate reductase, and then again forming ascorbic acid in this circle process. Vitamin C, this is very well known, nothing new. Can get from citrus fruits, and tomatoes are the best known source, but I'm not sure. You have to check how much one citrus fruit can give you vitamin C. Otherwise, you might as well end up with having to eat 10 orange fruits in order to fix your vitamin C daily requirement. Might as well get a supplement. Other vitamin C sources such as guava, broccoli, cantaloupe, red bell pepper, orange juice, strawberries, sweet potatoes, tangerines, spinach, leafy greens. And again, I just mentioned that you need to eat lots of these in order to get your daily requirement of vitamin C. For now, at the moment of we are in the COVID pandemic, might as well just get from supplement. Again, when you get vitamin C from your supplement, the bioavailability is the what we call it, what do we call it, the capability of your body to absorb that type of vitamin, is not that high. Maybe if you take vitamin C supplement of 1,000 milligram, maybe your body only capable to absorb 30%, maybe 300 milligram. The rest will be excreted from your body. So that's what the best type of vitamin C supplement that you can get from the market. It's called lysosomal vitamin C, but I'm not sure. I'll try to get it to find it in our country. We don't have suppliers in our country that can supply, that we can buy this liposomal vitamin C. If you Google it, you can find it in Europe, America. They have a lot of supplier there, but unfortunately we don't have that supplier that can supply us that type of liposomal vitamin C, because that's type of vitamin C can easily get absorbed in our body. Maybe 80% of the total um, dose that we get, maybe from 1,000 milligram of the liposomal vitamin C. When we eat that type of vitamin C, our body can absorb maybe hundreds, 100 milligram compared to 300 milligram that of the same type of vitamin C that we can have here in our country. So anyway, we we don't have that in our country. Just use whatever that we can find here. The deficiencies for vitamin C can cause weight loss, fatigue, joint pain, scurvy. Scurvy, the first uh, incident that by the sailors that came across that eating orange can cure scurvy. Um, reduce resistance to cold and infections because vitamin C fights infections. Slow healing of wound and fractured bone. Fractured bone. All right, the side effect of vitamin C. In general, water-soluble vitamin do not have side effect, but for vitamin C, it contains a number of side effects such as nausea, abdominal cramp, and diarrhea. So that's why lots of people, when at the beginning of this pandemic, I'm sure that most of us, we don't used to take vitamin C supplement, right? Siapa yang selalu, any of you, before pandemic, already take vitamin C supplement? Ada ke? Shin
Saya doktor.
Siapa? Who's that? Siapa yang cakap tu?
Danu.
Danu. Oh. So even before the pandemic, you used to take vitamin C supplement?
Yes, with like
Any-
other vitamins as well.
And any particular reason? Just, because of you
No,
want to
just
take care of your body.
yeah.
Okay, that's good. That's good. Nice to know that. Good to know that. Any other? Ada kan? So that's why at the beginning of this pandemic, when the doctor said you need to eat more vitamin, you get take vitamin C supplement. Most of us get nausea and abdominal cramp because our body not used to the high amount of vitamin C dose. So after a while, when you keep taking it every day, up to now, it's been about 2 years and a half of the COVID. Most of us do not have any effects of nausea and abdominal cramps anymore. For me, I take 2,000 milligram per day. Luckily, alhamdulillah, I don't have any of these side effects. Correct. These effects are due to the osmotic effect of unabsorbed vitamin C passing through intestine. As I just mentioned, from maybe I told you that I take 2,000 milligram per day. Maybe out of 2,000 milligram of vitamin C that I take, maybe only 500 can be absorbed by my body, and the rest will passing through intestine, causing osmotic effects. Okay, that's why the side effects of vitamin C can be seen as as nausea, abdominal cramp, and diarrhea. Okay, I think we stop at water-soluble vitamin, and we're going to continue the fat-soluble vitamin next Monday. 1 hour lecture to finish fat-soluble vitamin. And any question before we end our lecture?
Doctor.
Hello? Yep. Siapa tu?
Yeah, just Danu again. Just one
Danu.
small question. Yeah. So just now doctor said if I take like these vitamin supplements, like not everything will be absorbed by our body lah.
No, of course not. Less than 50% most of the time.
Oh, okay.
That's why, that's why when you think that, okay, I take vitamin C every day, it's good compared to for others that do not take at all. But still, if you take 500 or even lower than that, 200 milligram, it's not going to be absorbed. 200 milligram not going to be absorbed by your body. As I said, maybe 50%, 60%, we are happy with 60%, or 70%, even better. We are happy if your body effective enough, not going, and 100% not going to be happen in your body, right? That's why, as I mentioned, the I think the name is liposomal vitamin C. You can Google liposomal vitamin C. It's quite expensive. It's expensive, not quite expensive. It is expensive compared to vitamin C that we get here in our pharmacy. You go to big pharmacy or Watson in Seri Sedang, you take one vitamin C bottle or whatever brand. You look at the back. The name is ascorbic acid, right? Sometimes sodium ascorbate and whatever they use. You know, the type of vitamin C that they use also responsible to to increase the bioavailability of the vitamin. That's why they don't just simply buy any vitamin C. Go for the better brand. Maybe it's a little bit expensive, but you know, rather than you pay small cheap money for the cheap vitamin C, but somehow when you take it every day, but nothing happen, maybe 10% that your body can absorb. Might as well you spend a little bit, but your body can maybe the form of vitamin C that they use for that type of more expensive vitamin C, so your body can use it, can absorb it in more efficient. For example, 50 to 60 or 60% of the dose that you take. All right. So if you can try to Google liposomal vitamin C, I'm sure that we don't have it in our country. You can see that that type of vitamin C is expensive, but it's very good. Our body can absorb it very efficiently. Okay, because they put this sodium ascorbate in the liposome, which is the carrier. It's all about the carrier. We need to have a good carrier of the vitamin in order to that can pass through our intestinal cells. Okay. Otherwise, it just go to our intestine and straight away to our GI tract, um, um, to our gut, and then get excreted, just like that. What is going to be very wasteful. Okay. Any other question?
Doktor,
Ya, siapa ni?
Husna.
Husna Muhammad Noor.
Tak,
Bukan?
ni Husna Syahira.
Nama Husna. Benar, okey.
Tapi saya tahu yang teknologi sustain release for vitamin C ni kan doktor?
Siapa? Tak dengar lah.
Teknologi sustain release.
Sorry, I couldn't hear you properly. Technology? Did you say technology?
Yes,
Teknologi apa? Teknologi vitamin C?
sustain release for vitamin C.
Teknologi apa?
Wait, doktor.
Technology sustain release.
Okay.
Yang saya tahu, contoh dalam 100 milligram vitamin C yang kita makan, so dia akan release 500 milligram, contoh 500 milligram in 5 hours. So in 500 milligram tu dia akan absorb 50% lah macam doktor cakap tu.
Betul. Not all vitamin C, okay? You can find maybe some brands quite expensive for that one. Yang ada the cheaper vitamin C, you just eat it and just like that. You're not going to release it at the time. No. some of the vitamin C a little bit expensive. One brand, Blackmore's. Blackmore's, they have buffered vitamin C. When you take it, when you consume that type of vitamin C, they're not straight away being released, in your intestine. It's just kind of like slow release. So in a way that, instead of just release at one time and then your body cannot take it all and the rest going to be excreted from your body, this type of vitamin is which is slow release. You try to maximize your body capability of absorbing this type of vitamin, but still it's not that high compared to the lipophilic vitamin C because of the carrier. As I mentioned, carrier, because you need to have carrier. Sometimes nowadays people talk about nano carrier for drug delivery, right? They encapsulate this type of drug or vitamin in the nano material in order for them to be able to be passed through the cells. So now for the lipophilic vitamin C, they carry this vitamin with liposome. So with liposome easily be absorbed by the body to um, increase the bioavailability rate of this vitamin C. But as you mentioned, Usna, it's a good type of vitamin C as well. We call it slow release vitamin. It's quite expensive. It's cheaper than lipophilic. I cannot remember the exact name. Lipophilic vitamin C is cheaper. The slow release is cheaper than that one, but we can get it in Malaysia. You just go to big pharmacy or Watson, you can find it. You can buy it. That's why for the slow release vitamin C, normally the highest dose for one tablet is 500. They're not going to put it 1,000. 500 is enough because they're going to release slowly at a time in your body. Okay, any other question? Let me ask Luana Mendy. Are you here, Luana Mendy? We have one mobility student from France, Luana Mendy.
Yeah.
Luana, may I ask you, is it okay for you? Do you find it easy to understand my lecture or anything that you not very clear? Maybe on my English or whatever, the way I give my lecture. Anything that you want to say?
Oh, that's okay. I have just a question because I'm not, I don't have any access to Putra Blast. So
Putra Blast, yeah.
I was wondering if how I can have the support of the lecture.
Yeah, I will later on. I will try to contact the academic dean office to ask whether they can give you access to Putra Blast as soon as possible. And in the meantime, maybe I can email you this lecture note, because normally I just upload this lecture note in the Putra Blast so the student can download the lecture note or whatever material that I provide in Putra Blast. But for you, at the moment, you don't have access to Putra Blast. Maybe I can email you this lecture note later on. Is that okay?
Yeah, thank you.
Yeah, sure. Okay, any other question before we end our lecture? No more questions. All right. If there's no question, we end our lecture here, and we meet again next Monday at 2 p.m. All right. In the meantime, you can go through the lecture note and you can read the lecture note. And if you have any question, you can email me or you can text me. Okay. Tiga tak okay?
Okay, doktor.
Siap aja. Okay. Thank you very much and stay safe.
Thank you,
Thank you,
doctor.
doctor.
Thank you, doctor.
Thank you, doctor.
Doctor.
Right, welcome.